Today we're going to learn about percent composition. To do that, to introduce it, we're going to do a bubblegum activity. We're going to figure out the percent composition of sugar in double bubble gum. All right, so each of you guys in a few minutes are going to get a piece of gum. All right, what you're going to do when you get that piece of gum, you're going to go to one of two balances, guys. There's one over here. There's one over there on the counter. You're going to get the mass of the piece of gum and the wrapper. Do not throw away your wrapper. All right? Why do you think I don't want you to throw away your wrapper?
So you can wrap it like
Yeah, but we're going to reweigh it again, and what don't I want you to do? Put your nasty gum on my balances, all right? I don't want your saliva everywhere. You know, it's flu season and whatnot. So you're going to save your wrapper because we're going to reweigh it with the wrapper again afterward on the balance, okay? So when you have your gum weighed, you're going to start chewing it, okay? So if you have gum in your mouth now, you have to spit it out. Go to the trash, spit out your gum, because you need a new fresh piece of gum, a better piece of gum. All right?
That's in taste for 5 seconds.
Exactly. It's great for 30 seconds, and then... Guys, what I want you to do, though, at the very top of page 6, very, very top of page 6, in your packet, up there by, like, the hole punch holes, you're going to write before and after. Before and after. Because we're going to get two masses. We're going to get the before mass and the after mass. And from that, we're going to try and calculate the percent composition of sugar in this piece of gum. All right, so while we are chewing the gum, we're going to learn about percent composition. And then in about 10 minutes, after we do some practice, you guys will reweigh your gum to figure out the percent composition of sugar. So what percent composition is, folks? First off, does anybody remember the general formula for calculating any percentage? We learned it back in Unit 1. Not percent error, not average atomic mass, but any generic formula. Anytime you have to get any percentage, there's a generic formula for it. It's something times 100. Something over something times 100.
The mass of the element divided by...
We're not talking about this. I'm talking general, generic formula. Write it down in your notes again. There it is. Part over whole times 100, guys. Anytime you have to calculate a percentage of anything, whether it's mass-based, number-based, whatever, part over whole times 100 will get you your percentage. So, like, if you're a baseball player, to calculate your batting average, the part would be the number of hits you have. The whole would be how many at-bats you have. Baseball is probably the only sport, or the only profession, where you can fail more times than not and still be considered really good. A 300 batting average is considered pretty solid. Yet, that means you fail 7 out of 10 times. Crazy, right? Anyway, moving on. Guys, our part and whole here we're going to have to identify because we take our percent compositions based on mass. So it's the percent composition by mass of each element in a compound. So the work we've been doing already with molar mass and the way I taught you guys to go ahead and write and show your work makes percent composition very, very easy for us. So no matter what, no matter how big of a sample you have, the percent composition is always the same by mass. Put it this way. Water is what? What's the formula for water? H2O. So, when we look at the mass, guys, hydrogen has a mass of 1, so that's 2. 2 times 1 is 2, plus 16 is 18. So the total mass of a water molecule is 18 grams per mole. So when we calculate the percentage there, water is 11% hydrogen by mass, and 89% oxygen. That will hold true whether you have a drop of water or an ocean full of water. It's still 11% hydrogen, 89% oxygen. That's what we're kind of driving home here. You need to know this, all right, for your test next week. Regardless of the size of the sample, percent composition is always the same. All right, it doesn't change. All right. So when we get into calculations, guys, how we calculate it for our purposes in this class, we take the mass of the individual element that it brings to the table, and we're going to divide it by the entire molar mass of the compound and multiply by 100%. All right? So therefore, when we talk about percent composition, it's the percent that that element has of the total mass in the compound. All right, so let's kind of jump in here to a problem. We're going to figure out the percent composition of Cu2S. I'll give a prize, or we're going to tell me the correct name of this compound. Raising your hand. Nope. Raising your hand. Darius?
Yes.
Nope. Braden? Nope. What'd you say?
You didn't raise your hand, though.
Copper 1 what? Nope.
Everybody was saying
Tyler?
the same thing.
Well,
No. Josh? Copper 1 sulfide. Sulfide. Changing the end. All right, anyway. So, here we go, guys. Step 1, we're going to find the molar mass. How do we do that?
Periodic table and
Steps. Give me the steps, guys. Don't just say periodic table. What are the steps that we go through? The 4 subscripts. Separated out in each element, guys. And you're going to see why. You're going to see why I had you do it this way all along. It's going to help us for percent composition. So I've got copper. I've got sulfur. Now I will look at my subscripts. Copper has how many? 2. Sulfur has? What's the molar mass of copper? Sulfur is?
32.07.
That math is pretty easy. Now, 2 times 63.55, what do you get for an answer? 127.10. Now, to get the molar mass, what do we do? Add them up. Okay? We add them up, what do we get? 159.17. And what's our unit for molar mass? Not just grams. Grams over moles, guys. Molar mass. It says what that means is for every 1 mole, you have a certain number of grams. All right, so it's grams per mole. All right, so that's step 1. We've got to find the molar mass. Step 2, now we're going to find the percent. All right, so copper and sulfur, we keep those separated. You guys can already continue along with the work that you have, because if you notice and you look back here at sulfur, folks, it's already set up for us right here the way that we've written it out. By having the part of sulfur right here, there's our part of sulfur, here's our whole of the compound. All we have to do then is multiply it by 100. So I'm going to rewrite it over here. Sulfur was 32.07 over, was it 159.17? Multiply it by 100. All right? That's going to give our percent sulfur. Then copper, what was the part? It was 120.10 all over 159.17 multiplied by 100. Go ahead and do the math. What do we get? What is the percent copper then? Rounding to 1 decimal place, guys, it was absolutely okay. So give it to me to 1 decimal place. 59 point what? So 59.8. 79. Oh, I'm sorry. I did not hear you. 79.9% copper. And sulfur then is? 21.1%. So we have a built-in check, guys, to make sure you've done it correctly. What should all the percentages add up to? 100. Now, with rounding, do you think we're always going to 100% exactly every time? No, guys. Sometimes it might be 99.9. Sometimes it might be 100.1 or 100.2. That's okay. Okay? Because if we round, it's obviously going to be a little slightly off, and that's okay. Easy? Easy. All right. Let's try this one here together. This one is not in your notes. You need to write it down. You've got space there, guys, over to the left, down below your homework from the other night. You can write it in there. It says find the percent composition by mass of aluminum phosphate. What's our first step we have to do in this problem? What's that? What do you mean by naming? Before we can even separate it, what do we have to do? We have to write the formula, guys, and these are the types of problems you're going to see throughout the year. You have to be able to go from a name to a formula. Aluminum phosphate. I've got a metal in there, so I know it's ionic. What method do I use for ionic compounds? Crisscross. So aluminum's charge is? Phosphate's formula is? Charge? -3. Crisscrosses up. Now, what's my formula going to be for aluminum phosphate? Yeah, right, because those 3's will cancel out. There it is. Now I can go through and separate out each individual element. So I've got aluminum. What else do I have? Phosphorus and oxygen. How many aluminums do I have? Phosphorus, oxygen. Molar mass of aluminum is 26.98. That math is easy. Phosphorus is, that math is easy. And then oxygen, does anybody have it memorized yet? 16. Told you you'd memorize that one real quick. 4 times 16 is? That's probably a number, guys, that you'll memorize very quickly as well, because a lot of compounds have 4 oxygens in them that we find out for whatever reason. Go ahead and add them all up. What's my total molar mass here? $121.95. Right. Now, guys, we actually don't need to worry about the units here because we're not going to end up with grams per mole at the end of percentage. It's just percent. All right. So notice right here, oxygen is already set up because of the way we've written it out. All I have to do is put times 100. There's my percent. Then up here, I can just go 121.95 right below it times 100. There's that one. Same thing here. 21.95 times 100. There we go. Go ahead and do the math. Get your percentage for each individual element. Anybody got aluminum? What's the percent? 1 decimal. 22.1%. Phosphorus. What'd you say? 25.4%. And somebody else, oxygen should be the biggest percent. 52.4. What'd you say? 0.5. I'm okay. There you go. Easy? You guys are doing the 2 U-Try problems that are there on your notes at the bottom of page 6. When you get done, so the answers are already there for you. You guys can check your work. But when you get done writing out all of your work, you're going to take your piece of gum, put it back in the wrapper and fold it up, get the mass of your chewed gum, then you are throwing that piece of gum away. Do not put it in the recycle bin, put it in the trash can, and then you are working on your review page at the end of your packet while we wait for everybody to get their mass of their gum.